I'm Burak. I'm working as a software engineer at the Microsoft. Today, I'm gonna present you how to scale your Postgres database for time series data with Citus. All right, the outline of the presentation is like that. I'll mention about what is the time series data and what is the time series workload. And I'm gonna mention how you can use Postgres and Citus capabilities to make your time series workloads manage easier on your database on the single node. And I'm going to mention what is the Postgres built-in partitioning, what is the Citus way to simplify management of those partitions, and what is the Citus Columnar and how you can use it to save on storage and also improve the query performance of your on your data, on your time series data. And I'm going to also mention how you can use the PG cron, which is another extension created and developed and maintained by our Citus engineers, and how you can use it to schedule and automate your partition management. And I'm gonna end my presentation how you can distribute your partitions across the nodes in the Citus cluster. And I'm gonna show all those things in a demo at the end. So what is the time series data? So we can say the time series data is a kind of a measurements of a collection of data, and it's observed over time. So we can say the IoT applications, data of IoT applications, monitoring tools, financial data trackers, analyzers are good examples of the time series data. So we can say anything, any kind of data changing over time can be counted as a time series data. And I also want to mention what is the time series workload. So as I said, we can say anything changing over time with the values. I mean, the value of it over time can be counted as a time series data. And we can say the time series workload has some characteristic which is generally different from the other usage of the databases. Generally, appending the data instead of updating individual tuples with the time series workload. So instead of doing some random updates on your individual tuples of your data, you generally append data at the end of your data with the time series workload. So if you insert your data, as I said, you are adding your data at the end of your data range, or you may also want to add your data as a batch data for your all time as well. And generally, people query their white data, which I mean with white data using lots of columns of from their tuples for the latest range. But if they are planning to use the data from the old range, from the, let's say, the old time from your data, they generally make a query on the fewer number of columns. So we can say people generally querying their narrow data from old range. And time series data is, or time in the time series workload, data is accumulating very, very, very quickly. So, I mean, as I said, I mean, the data can accumulate very quickly, and you need to manage that accumulating data with your database. And Postgres has a built-in support for partitioning your data. Because I mean your data can grow, I mean because of the nature of the time series data, I mean quickly, and can cause your database to slow down over time. Partitioning that data into smaller partitions or smaller chunks make your queries faster, because I mean you basically need to deal with smaller chunk of the data, and having a smaller chunk means I mean the smaller indices, I mean, having a better performance for other queries as well. So having partitions for your, let's say, the partition table with smaller chunks generally improves your performance within the Postgres. And in order to create partition table in the Postgres to have, I mean, the smaller chunks for your whole data, you need to create first a partition table with a Postgres commands create table with the partition by range at the end of it. As you can see from the comment, we are right now creating a time series events table, which is partitioned on the event time column, which is a timestamp, I mean, has a timestamp data type, by the way. People generally use, I mean, if they want to partition their data by range, they generally use columns with timestamp data type. And after you create your partition table, you also create the partitions to store the subset of your data as defined by its partition bounds. So as you can see, when we want to create a partition of the partition table, we are creating our table with the partition of comments, and we are saying that we are creating our partition, which right now we have named as let's say the 15th of the April, keeping the data for the 15th of the April, for example, for the 22. So we just say that's the table name, and we have added the information of which partition table will keep our partitions for which range, and we have, let's say, mentioned that range as a part of the create table command with the 4 values from that date time to the that date time. So, and afterwards, if you, let's say, want to ingest your data to your partition table, you can use the well-known insert into command, and you can use the partition table name while inserting data to your table. So you don't need to use the partition tables, but you can use the name of parent partition table instead, and Postgres will understand it and will route to the right partition according to the bounds you have provided to the Postgres. And as I said, using the Postgres built-in partition, you can utilize the resources of the node you are running Postgres on, the more wisely, because basically you have partitioned your table into multiple partitions, and you have right now you have, let's say, chunks which are keeping your data for a given range. And as I said, it makes your life easier while managing your the whole data. But you need to spend some time to manage those partitions by yourself. As I just shown with the previous slide, you need to create your partitions, and just like creating your partitions, you also need to drop your partitions as well when you don't need them anymore. But using the Citus, you don't need to manage your partitions anymore manually. We have introduced 2 different UDFs, which is user-defined functions, to the Citus, so that you don't need to think about managing your partitions by manually, let's say, anymore. So we have create time partitions and drop all time partitions commands. And as you can see, you need to provide the table name, the partition interval, and start from information to the create time partitions. And that function will create as many partitions as necessary for the given time range and for the given time interval. So if you, let's say, you want to create daily partitions for the next 7 days, you can provide the interval as the day, and you can provide the writes and start from timestamp to that function, and that function will create all the partitions for your needs. And let's say if you want to drop some partitions, if you don't need them anymore, you can drop them, which is generally the case with the Timeseries workload as well. So if you want to drop, let's say, the partitions older than a given timestamp, you can also use the drop all time partitions, which basically needs the table name and the timestamp value to drop all the partitions older than the given timestamp. So, for example, as I have mentioned in the previous slide, so if you want to create the daily partitions from the 15th of the April to the 30th of the April, you can just provide those dates as end date and the start from, and you need to also provide the name of the partitioned table to that function, so it will create the partitions you need. And let's say if you want to drop the partitions, which is older than the 30th of the January, you basically call the drop all time partitions method, and it will drop all the partitions older than the given time. And compressing the data is another want the people want to have with their, let's say, the time series, with managing their data with their time series workload. Because as I mentioned, with the time series workload, you generally need to create partitions for the future. And sometimes you also want to drop some of your partitions if it is older than a given time. And with the Citus Columnar, you can also compress your, let's say, the partitions before a given time. I mean, you can also use the Citus Columnar for changing the access method, which basically changing the access method from heap to columnar. As you know, the heap is the way of Postgres keeping the data. And if you want to compress that data, you can use the Citus Columnar's alter table set access method to, let's say, compress your tables. And I mean, the row-based tables are generally good for transactional workloads because, I mean, let's say you need to, you generally want to fetch the data of the tuples for multiple columns. But you can also use the columnar version of your tables for analytical workloads. And if you want to combine that with the partitioning functionalities of the Citus, you can also use the alter old partition set access method to compress the partitions older than a given timestamp. So, for example, let's say you have a Timeseries workload and you want to, I mean, create partitions for the future, I don't know, 7 days or so, and you want to drop your partitions, I don't know, older than 30 days, you can use the two UDFs I have shown before in my slides. And if you want to compress your partitions, let's say, I don't know, older than 15 days, you can also use Citus. The Citus Columnar is a part of the Citus extension right now. So you can use the alter old partition set access method to compress your partitions older than a given threshold. So, I mean, the signature of that function is similar to the other UDFs. You basically need to provide the table name and let's say a given timestamp, which, I mean, the function will change your access method. As I said, you can use that function to compress your data. But if you want to uncompress your data, I mean, for any purpose, for example, right now, Citus does not support updates and deletes on the compressed tables. So if you want to update your, let's say, the old partitions, which is generally not the case with the Timeseries workload, but I mean, probably because of an issue on your data or any other thing, if you want to change your access method back to the heap, which means uncompressing your data, you can again use the same function by providing the last parameter as the heap. So you can, I mean, both compress and uncompress your data with that function. And as I said, having partitions stored, I mean, in a columnar fashion can also increase your analytical query performance, because generally with the analytical query, people query their data, their rows with not so much columns because of the, I mean, the analytical purposes. And because the columnar, I mean, the compressing the data with the Citus will, let's say, keep the data in a columnar fashion, it can improve the performance of your analytical queries as well. And in addition to, I mean, improving your analytical queries, you can also have indices on your compressed tables. So let's say, I mean, if you have a partition table and if you want to, let's say, create the index for your partition table, you can directly create index on the partition table, and Citus basically will support, let's say, the indices on your partition tables by default. You don't need to do anything else, even if you have a compressed partitions for your partition table. And I mean, as I said, I mean, we have improved our partitioning management from running the Postgres commands, the create table or the drop table commands, using the Citus way of creating the partitions for given time range, and also dropping the partitions older than a given timestamp. And we have also introduced the compression with the Citus to the Postgres. So you can use the compression, as I just shown, to compress your data, I mean, for any table, or you can also, I mean, compress your partitions older than a given time. But if you want to automate those jobs completely, I mean, if you want to automate creating those partitions, dropping those partitions, or compressing those partitions completely, you can use the pgcron. pgcron is another open source extension which is developed or created and maintained by the Citus team to schedule cron-based jobs on the Postgres. So you can use pgcron to schedule, the Citus functions, as I mentioned, for creating, dropping, compressing partitions. If you want to use pgcron for any other purpose, you can use it as well. So as an example, so let's say if you want to, schedule cron jobs in your database to create partitions for the next 7 days, you can schedule a cron job, a daily cron job, and you can give the create time partitions, which is a part of the Citus I have just explained, to that function. And when you schedule that cron job, the pgcron will run that function you provided to the cron in a daily basis. So you don't need to think about, the creating your partitions anymore for the, let's say, the next 7 days, and creating, let's say, the daily partitions for the next 7 days. And if you want to also automate the compressing your data older than, let's say, the 5 days, you can also automate that job using the pgcron again. You can schedule another job, a new job. You can name it as compress partition. You can give any name you want. And again, you can, let's say, schedule it daily. You can change the schedule, by the way. You can use the cron-based information on the cron schedule, so you can change it to anything else from the daily. But right now, for our purpose, we are using daily schedules. So you can again schedule your alter old partition set access method again to compress your partitions, which is older than 5 days, and you can completely forget about compressing your partitions older than 5 days, because pgcron together with Citus will handle compressing your data. And if you want to expire partitions older than some given days, I have provided the 7 days here, but if you have another rule for your workload, you can change it to, 30 days, 3 months, whatever you want. And you can again schedule that job to drop the old partitions, which is older than a given time. Because it accepts those functions accepts the column as a timestamp. You can provide the timestamp as now minus something, so that when the cron job will run daily, it will, let's say, drop the partitions older than 7 days, because the now basically present the day the scheduled job is running. So basically, providing that information, you can completely forget about creating partitions for the next days, compressing your partitions, older than, what amount of day, what amount of month you want, or expire your partitions again older than a given amount of time. So, and you can do all of those in a single node Postgres, because the Citus supports adding itself as an extension on the single node, let's say the Postgres. So if you don't want to scale out your data at the beginning of your workload, you can start sharding and partitioning on the same node. So what you want to do for sharding and partitioning your table is you need to decide on another column which basically shard your data in addition to partitioning your data. So basically, to shard your data, you need to decide on 2 dimensions. For the time series data, people generally use partition by time if they are partitioning their data by range. And as you remember, we have already partitioned our table with the timestamp column. And what you need to do to shard your table, in addition to partitioning it, you need to run the create distributed table command of the Citus to shard your data. Again, the only thing you need to decide is you need to decide on the, let's say, the sharding key of your table. You can check the Citus documentations to understand how you can decide on the sharding key for your table. But once you run the create distributed table command on the partitioned time series events table by providing a sharding key, the Citus will shard your partitions, and you can use, let's say, both the sharding together with the partitioning in your database on a single node. So if we want to show it in a graphical way, so basically we have partitioned our table. Those are the partitions, and if you shard those partitions on the single node, Citus will shard each of those partitions to a given number. It is a 16 over here. So in the single node Citus, you can shard your partitions, and you can use best of both Citus and Postgres to manage your, let's say, the time series data. If you want to distribute your, let's say, the sharded partitions, you can follow two different ways. I mean, you want to basically distribute your sharded partitions because, I mean, with the time, the resources of your node can become a bottleneck. Because as I said, the data or the time series data accumulating very quickly. So if you want to scale out, you can do it with the Citus as well, very easily. There are two options. First, you can start using Citus with multiple nodes. And if you are using multiple nodes from the beginning, using create distributed table will distribute your shards along the cluster. But if you have started with a single node, and if you want to scale out afterwards, you basically need to add a node to your cluster with the Citus add node UDF function. You basically need to provide the name of your, let's say, the node and the port of it. And after adding your data, you also need to, let's say, rebalance your data to make sure that you put the data from the old nodes or the, let's say, the initial nodes to the new nodes. And if we want to show it graphically, I mean, with the single node Citus, we have partitions. We have sharded our partitions. And if you want to scale out those, let's say, the sharded partitions, you can basically add nodes to your cluster. And after adding nodes, you can basically run the rebalance table shards commands to rebalance your sharded partitions on the, let's say, the multi-node Citus cluster. As I said, if you want to use, let's say, the multi-node Citus cluster from the beginning, using create distributed table will basically distribute your shards, your, let's say, the partition tables, or shard your partition tables on the multiple nodes. So it is the end of my presentation. So let me continue with the, let's say, the demo right now. So for example, let's create a time series events table, which you can see, as you can see, it's the partitioned by range, and it is the time, has a timestamp data type. And let's create some, let's say, the partitions for your partition table. As you can see, we have created our new manual partition for the time series events for that range. And as I said, you can also insert the data to your partitions, and basically Postgres will understand which partition it should use. And if you want to query your, let's say, the time series events, Postgres again understand and will return back to you the results. And as I said, you can change the access method of your partitions. As you can see, I have used alter table set access method to change the access method of my table to compress my table. So we can have a hybrid partitions for our partition table. So as you can see, I have created a new partition for my partition table, and you can check all of your partitions within your Citus database using the time partitions column. So basically, you can see the time partitions from that table. And as you can see, the access method of the first partition is columnar, and the second one is the heap. So the first one is compressed and the second one is not. And you can even create indices on your time series events table, on your partition table. And as you can see, we have our indices on both the compressed one and also on the uncompressed one. So as you can see, we have managed our partitions manually right now. So let's drop that time series events table and use the Citus functions to create our, let's say, the partitions automatically. So as I mentioned on my presentation, you can use create time partitions commands. And as you can see, we have just right now used the minutes instead of the days. So that command have created partitions for, let's say, both the 7 minutes before the current time and also the 7 minutes for the next time. And as you can see, we have in total 15 partitions for our table. And you can also, let's say, use the alter old partition set access method to compress your partitions older than a given time. And you can also drop your partitions as well, again, using the drop all time partitions method. And if you check your partitions again, as you can see, we have dropped the partitions older than 5 minutes, and we have also compressed our partitions older than 3 minutes. You can also schedule jobs to, let's say, automatize, let's say, handling those, creating, dropping, and compressing those partitions. As you can see, we have automatized partitioning creation, compression, and also drop partitions with the cron jobs. And if you want to, as I mentioned, create a distributed table or want to shard your partitions with the Citus, you can also use the create distributed table command. And as you can see from the pgdist partition metadata table, you have right now sharded all of your partitions in addition to your parent partition table. And if you want to scale out your cluster and if you want to add more node, you can use the Citus add node function, and you can add a new node to your cluster. And if you want to scale out your partitions on the multiple node, you can also use the rebalance table shards, which basically move the data from old partitions to the new one. That is the end of my presentation. Thanks for listening. I hope you'll enjoy using Citus together with Postgres' own functionalities to manage your time series data with our solutions. Thanks.